Rotations. Rotations are a transformation in which a figure is rotated or turned about a fixed point. Today's video is going to focus in specifically on what if that point is not the origin of the graph. So we've talked about, or will talk about, specific rules that help us when we're rotating about the origin. But in this video, I want to focus on when our center of rotation, the fixed point that we are rotating around, is a point that is not the origin. Now, the rules here are the rules for about the origin. If you do not have these written down, I need you to pause the video and write these down now before you move forward. The rules we're going to focus in on right now are when I want to rotate about any point on the graph. And there's a couple things that I need you to pay attention to. First, in these rules, we have X and Y and then A and B. The X and Y will come from whatever my center of rotation is. And that'll be dictated to you. You will be told exactly what that center of rotation is. After I have that, I will then go to the graph and look at your horizontal and vertical distances. We're going to use the skills we've used to find slope and to find distance to help us plot our new points after the rotation. You need to pause the video and write these down before moving ahead. We're going to start with this example. It says triangle XYZ has these vertices, graph triangle XYZ and its image after each rotation. I'm going to do two of them. Then give the coordinates of the vertices of the image. So to start, let's put on the graph X, Y, and Z. X, Y, Z. We have a right triangle, and we're being asked to rotate 180 degrees about vertex X. Meaning I'm going to take X and spin my picture around it. It's much like if I were to stick my finger down on a piece of paper and turn the paper. The spot that my finger's on, the paper just spins around it, but that one spot still stays under your finger. That's what we're going to do. It's like a pinwheel. In a pinwheel, you have the pin in the middle that the rest of the piece spins around. So that's going to be this point on the graph. We want to figure out where X prime will be, Y prime, and Z prime. To start, X prime will not be moving. X prime will just be the same point X is, because that is our pin. It is stuck there. It is nailed in place. We're just going to now spin it around that nail. For 180 degrees, our rule is X minus A, y minus b. So we will have to count the vertical and horizontal distances from x to z and y separately for us to find these points. I need to recall that x and y are going to come from my center of rotation. It's supposed to come from our point at which we are rotating. So that point, x was 3 and y was 1. Let's talk about now how to find y prime. For y prime, I need to know, first off, that x is 3, y is 1. And then I need to figure out what is a and b. So I can subtract those from 3 and 1. For point y, I have a vertical distance, my b, of 6. And then as for my horizontal, my left to right, that is 0. And I can plug those in. Becomes 3 minus 0 and 1 minus 6. 3 minus 0 is 3. 1 minus 6 is negative 5. And now I can graph the point y prime. Let's talk about z prime. Z prime, we're going to start off with the same idea. I'm going to start with the 3 and the 1, and I need to figure out what is it I am subtracting from each of them. So A, the horizontal, and B, the vertical distances. For Z, I do not have a vertical distance, so that's 0 for B. And A is 1, 2, 3, 4. And now I can plug that into my rule. X minus A becomes 3 minus 4. That's negative 1. Y minus B is 1 minus 0, and that is 1. That places Z here at Z prime. And now I have this right triangle. You need to ask yourself, are those the same exact triangles? Yes. But now they are facing a different direction because we spun it around. So let's take a look now at what about a 90 degrees clockwise rotation. So I have the same pre-image. X, Y, and Z. But this time, I'm going to do a rotation around point Z, meaning Z is not changing. Z is nailed into place. I need to figure out where am I going to graph X prime after I spin it around and Y prime after I spin it around. Remember, the center of rotation, Z, is also Z prime. So for 90 degrees clockwise, the rule is X plus B, Y minus A. Recall that X and Y are going to come from my center of rotation, which is Z. I will highlight that again so you see what's connected. And I'm going to need to go in and figure out what are my values for A and B. And we'll start with X prime. For X prime, I'm going to have 7 plus B and 1 minus A. And I need to figure out what is A and what is B. Starting at Z, I have no vertical distance, so B is 0. 7 plus 0 is 7. And now I'm going to figure out, what about my new Y value? I need to know that A, that horizontal distance. Starting at Z, that's 1, 2, 3, 4. Now I counted to the left. When I count to the left, that is negative 4. So direction is important. Negative 4. So I have to do 1 minus negative 4. And if you remember, minus a negative makes it a positive. So 1 minus negative 4 becomes 5. So I have my new X value at 7, 5. X prime. Next, we will find Y prime. It's X plus B, 1 minus A. And let's figure out what each of those are. Starting at Z, my vertical to get to Y is 1, 2, 3, 4, 5, 6. Up is positive, so positive 6 for my B. For my A, that's 1, 2, 3, 4 to the left. So that's negative 4. So Y prime has an X value of 13. And a Y value, let's see, 1 minus negative 4 becomes 1 plus 4, which is 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let me double check that. Here is Y prime, and I can make my right triangle. So we need to ask ourselves, is that the same triangle? Visually, we should be able to confirm that yes, they are the same. Only difference is it has now been knocked on its side by doing a 90-degree rotation around the vertex Z. Some points that were brought up that are going to be important here. When I have my graph, remember that for this, if I count to the right, that's positive. If I count up, that is positive. Down is negative and left is negative. The direction in which you count will decide whether you have a positive or negative number. And that is going to be very important when you are trying to find your A and B values.